continue looking at rational expressions today. We have done simplifying, we've done adding, multiplying and dividing, and today we're going to do adding and subtracting. But before we get there, we're going to review factoring because factoring is important in all of these. So first, remember what we always do first with factoring? Check for a GCF. Hopefully that's what you thought in your head. So take a GCF out of this one. We get x squared minus 9, and x squared minus 9 is a difference of squares. So x minus 3, x plus 3. All right, so today, like I said, we're going to look at adding and subtracting. In order to add and subtract, you have to have a common denominator. You might remember that from when you were doing fractions. In order to add or subtract fractions, you have to have a common denominator. Same thing is true when the fractions get crazier and we call them rational expressions instead. So one thing you're going to have to choose every time is something called an LCD. LCD is a least common denominator. So we need a denominator that both of these denominators would divide evenly into. And we need it to be the least. So if we go something simple like a fraction, and we're trying to find a common denominator for 1/2 and 1/4, well, both of those divide into 8. They both divide into 12. They both divide into 100, but none of those are the least common denominator. And you probably can look at that and say, well, yeah, they both divide into 4. Okay, so 2 and 4 both divide evenly into 4. So you always need the least common denominator. So what would 9x squared and 3x both divide evenly into that would be the least common denominator? Well, 9 and 3 both divide into 9, and x and x squared both divide into x squared. So 9x squared would be our LCD, which our first fraction already has. Our second fraction doesn't, so we have to fix it so that it does. Back over to our simplified fractions, we said that 4 was our LCD. We can see that one of these already has 4, but you might recall, in order to make this one 4, you have to multiply the top and the bottom by whatever gets to 4. So now this one would be 2/4. Same thing over here. We'd have to multiply this by whatever it would take to get to the LCD. So we're going to multiply by 3x on top and bottom, because whatever you do to the numerator, you need to do the denominator to keep the fraction equivalent. And if we multiply them both by 3x, we will get a common denominator. So our first fraction stays the same, 5 over 9x squared plus 21x over 9x squared. Now you'll see our denominators are the same. Once they're the same, we can add. All right, so our numerators, when we add, you add straight across, horizontally. So we add numerator to numerator, 5 plus 21x. Those are not like terms, so we cannot combine them together. So 21x plus 5 is as simplified as we can get. Now when you do the denominators, you don't add them together, you just keep the denominator. So it is 9x squared. For that common denominator. All right, let's give it another try. See if you can look at this one and determine what the LCD would be. And if you know what it is, what would you have to multiply each fraction by to get to that LCD? So hit pause, take a minute to figure out the LCD, and then come back and check. All right, this LCD, we would need numbers. You have to take each one of these pieces individually. So a number that both 2 and 6 go into, 6. A number that both x, or I should say a variable, that both x and x squared go into, that would be x squared. And a value for y squared and y would be y squared. So our LCD is 6x squared, y squared. If we look at just this first fraction, we'll notice that the 2 is not the 6. We're going to have to multiply it times 3 to make it 6. The x is not the x squared, so we're going to multiply it times x to get to x squared. Now the y squared is y squared, so we don't have to do anything with the y. So it looks like we are multiplying numerator and denominator by 3x. On the second fraction, the 6 is good, the x squared is good, but the y isn't y squared. So we have to multiply numerator and denominator by y. All right, so that leaves us with 15x, we multiply those, minus 1y, or just y, all over our LCD, 6x squared, y squared. All right, last one for this session. Again, we're going to need to do an LCD. However, this one's a little different because we need to factor before we can state our LCD. So x squared minus 4, hopefully by now you're familiar with that difference of squares. So that would be x minus 2, x plus 2. And you can see now that when it's in factored form, it's easier to compare. So we can see that they both have an x minus 2, but this one over here doesn't have an x plus 2. So our LCD would be x minus 2, x plus 2. And our first fraction wouldn't have to be multiplied by anything. But our second fraction would have to be multiplied by the x plus 2 that was missing. Okay, so our first fraction, like we said, stays the same. It would just continue to be 2x. And then our second fraction, we're going to take this minus 4 times x plus 2. And then our denominator is our LCD, x minus 2 times x plus 2. All right, so we're not done yet though, because we can simplify it some. We're going to distribute that negative 4 all the way through the parentheses. So 2x minus 4x minus 8 all over our LCD. And then we can combine our 2x minus 4x. 2x minus 4x is negative 2x minus 8 over our LCD. And then we even have one more step to go after this. Once you've simplified, you need to look to see if there's anything else you can factor. And our numerator has a GCF, so we need to take a GCF out of our numerator. So if we divide out a negative 2, we're left with x plus 4. And you always want to leave things fully factored. So notice that we're not rewriting this denominator as x squared minus 4. We want to leave it fully factored because sometimes we could divide factors out. Not in this case, but everything in your final answer should be fully factored just to make sure we don't have anything that could or should be divided.